That's okay. I can go.
Hello everyone. So good morning. So it has been a wonderful morning. So I'm Bharat from. I'm working for Horizon. So Horizon DevOps developer at Horizon. So earlier I was working for Accenture. So Bangalore. Recently I came to Chennai. So meeting you guys. Earlier I was part of Bangalore DevOps community. So I was searching for a meetup community in Chennai. So it's fascinating that AstraZeneca is sponsoring it. It's a great thing. So this culture it promotes innovation, so we should keep going. So hats off to AstraZeneca for arranging this and organizing this. So next today's session, so it's a very interesting session. So serverless. So if you see, on the same day in April 8 in Bangalore DevOps community, there is a presentation same time going on serverless by AWS. So serverless is everywhere. If you see, it has become a buzzword around the industry. So in this presentation, we're going to discuss what is so exciting in that serverless. So what are the basic core components of serverless? So not only theory, keep light on my slides and I'll show you the real-time applications. I have built a small application. So it's like a meetup mojo. So you need to enter the meetup name so that it will get you the details from the backend, like where it is, what date it is, time, and the venue. Going to see how that we are going to see the different layers of that particular app. So, for example, in a database layer, we have used DynamoDB, whereas in DAO layer, so that's where our Lambda comes in. Okay, so that there we have used AWS Lambda. Of course, you can go for, so some will be thinking like whenever I go for Lambda, so there is a vendor lock-in. So you can avoid that. Even Google, as Google Firebase offers some Lambda. So whenever you're designing such Lambda function, you need to design it such a way that you can, it should run whenever if you want to change it to either cloud provider, so that at very minimal effort, so that there is no vendor lock. So next, there is observe functions also. So we will touch base on that, and we'll discuss about some of the serverless framework available in market, so which you can use if you're starting a serverless framework. Yeah, this is pretty much me. So I'm working for Horizon. So there is a I'm co-organizer of another one meetup, also Jenkins area meetup. So we're doing it with Cloudbees. So if you had a chance, you can go to meetup page and search for us and join us. So maybe in future we can coordinate with AstraZeneca, Cloudbees, and Horizon, so we can conduct a inclusive meetup. So we're looking forward to that. And so that even we spoke with Cloudbees. Soon we will be having. You should see the meetup session. So check it out and join us there. So this is the agenda pretty much. So we're going to discuss what serverless does not mean actually. So there are lots of misconceptions about serverless. So we're going to bust out that misconception and understand what exactly serverless is. And next is we're going to see about the entire architecture. So what Amazon calls as the golden standard. So in order to create a highly available application or any application, so you needed to replicate it over two different regions. So what is the disadvantages in that? We will see in that. And next is we will see about the serverless architecture, how a serverless architecture will look like. What are the different components, co-components that involves in a serverless architecture? So what are the considerations? What are the analysis you needed to do before going for serverless? Those things we will discuss. And whenever I'm showing my application, I will whenever you go for AWS Lambda, right? There are certain resource limits, throttle limits. Okay, so we're going to discuss about that. And next, we will go to the serverless concept. So this serverless concept, what I will do is now I'll not cover in slide, but practically I will go to that application. I will see you that where that particular concept is being applied so that you can understand it better. And next is serverless use cases and examples. We will see about the production examples of serverless where we are using. So there is a company called a scientific company called Compelling. So they're using serverless, and we'll see how we will touch base on that as well, and then we'll open up for Q&A session. So that's pretty much for this session. So what serverless does not mean? So serverless does not mean there are no servers involved. So when you think, soon after I said the word serverless, you would have thought, okay, there is not going to be any server, but actually in the backend, there is servers. So, but Amazon has abstracted that server. So it's a managed service, like kind of, okay, service for you. As a developer, I don't have, it has been abstracted from me. Okay? So I don't have to worry about my server. So whether it's auto scaling or load balancing, so those things and all I don't have to worry about. So that is the whole point. So even there is a chat going on whether to change that name to something else. Okay, so so rather serverless means developer don't have to think about servers. So that's what it's abstracted from us. So you offload your responsibility to someone else you can trust, like that is your cloud provider. So whether it's Google Cloud or AWS, so you offload your responsibilities to them so that they can take care of your servers. And next, instead, what you're doing is you're plugging in an elastic computing services. So you don't need to provision the resources based on load. So like so soon after in few minutes, we will see the URL. So you can all try to hit that particular URL. So it will scale up automatically. So I have not configured any load balancer or auto scaling. So if I had configured the same web application in a T2 micro or T2 medium, it would have been, so it would go down. So actually it will become not accessible because so many hits are happening. So, but since it's in serverless application, you'll see that it scales up whatever requests it comes in, it scales up and it attains all the requests. And next is you don't need to do a lot of planning about like on-premises. So if you're going to do on-premise, even on AWS cloud, you need to consider different things. Okay, so what is my application, whether it's compute, whether it needs a compute optimized instance, or whether it's storage or optimized instance. So those things and all we need to consider. It's based upon application nature. So whether it's a web application which is going to have a high load, it's a batch processing application where it has lots of database read, right? Those kind of things. So those things you don't have to worry about in serverless. Everything is taken care of. And next is growing the app happens on demand, like I told. So soon after you would, based on the number of requests that is coming in, it automatically scales up, scales out on the back end. So you don't have to worry about it. So soon after the requests goes down, it automatically scales in. So you don't have to worry about it. So that's pretty much. Just serverless. So let's see like journey to serverless. Like how software evolved in. Okay, like so we started with mainframes and then we added distributed systems. Next came the internet. Okay, so and afterwards mobile application revolution happened. So then public cloud came. We all migrated to. Of course, with public cloud, right, we offloaded a lot of our responsibility to AWS, but still there can be improvement using. So and finally it's serverless. Okay, so every organization is thinking how to use optimized use of this thing, optimized use of cloud resources so that they can minimize the cost on cloud. So that's all about serverless. So this is a typical entire architecture. So how a typical high available web application will look like. So you can see that there is a backend. This is a data tier where all my DB tier. You can see that there are two regions. Okay, so one is primary region and another one is going to be a passive region, so which is a failover region. So one region goes down, so it fails over to another region. You see, right? So you have all the complex DB servers, and then DO model layer, data accessing layer, where you have app server, and again for integration you have one app server, and for presentation you have a web server. Okay, to replicate it in another environment. So if you need a highly available application, so what happens? It's like even though you're not using it, you're going to pay for it. Okay, so that's the whole thing. Okay, so for something we don't use. So with Lambda, so we'll see how this particular architecture is being improved. Yeah, this is how typical serverless architecture will look like. So whatever we constructed, right? So the application you're going to see in a moment, it's going to be something like this. Okay. So I've not used CloudFront, but of course I've used S3 for my presentation. You can see all my HTML and client files residing in my S3 bucket. Okay. So from there, I'm calling the API. I'm using the API. So Ajax call. I'm making an Ajax call to my. Then I'm accessing the API. From there, it goes to the Lambda, and then it interacts with DynamoDB. So soon after you hit my URL, which I'm going to give in a moment, what will happen is to go to the S3. So it'll hit the static HTML page, okay, which is there, and that static HTML page makes a JOX call to my API gateway. That API gateway, what will happen is it will interact with AWS Lambda functions, and then the Lambda functions. Actually, you can see that many earlier one of the Amazon has enabled last trigger. It's like using you can use Lambda in VPC. So that's one of the things. Earlier there was a concern, like since Lambda can access your backend, you may be having a confidential data in your database, right? So whenever it's exposed to internet, so that can't be allowed. Even in Verizon, right? So they never allow something which is outside VPC. So due to the security concerns, so everything whatever we do, it should reside in our VPC. So that's what this feature was enabled. So from since this feature is enabled, now Lambda has become more powerful. So from VPC within you can connect to all your resources, not being exposed to the internet. So that's the beauty of it. What will happen soon after we hit, it comes to from S3, it comes to a Lambda gateway, it passes whatever the JSON format it is getting. A Lambda function reads the JSON, and then it queries the database, it gets the result and posts the JSON back to my API gateway. API gateway gives back to my HTML file which is residing in S3, and it displays in the here. That's how whole process happens. Yeah, so and as you know, Lambda is a stateless function, so it's not going to hold your session information or something. If you wanted to do something, so you can either do it in a you can go for DynamoDB or Amazon RDS or Elastic Cache. So DynamoDB is a NoSQL database. So if you need an RDBMS, then very well you can go for Amazon RDS. Okay, so relational database. If you need relational database, you can go for Amazon RDS. So Lambda works well with that aspect. Okay. So microservices architecture. So we are not really restricted to that one only. You can use Lambda even in order to construct microservices architecture. So so this is one trending pattern. So if you see, lots of people are talking about containers, and upon that microservices. Okay, so at each container they're creating a separate container for microservices. Okay, so whenever you go to Lambda, it's very complex. You need to again maintain that container, everything. So it's very complex. So once you go to this particular model, right? So you offload that complexity. So this is a typical. So for every, you can create even nano services using AWS Lambda. So where it's a very small service. Okay. So why we are doing this microservice or nano service is so that you can decouple your application. Okay. So deliver faster to customers. Okay. You can create value. So you don't have to wait about many days in order to go through the complete cycle. Okay, so it will be very fast. So in case of this. So serverless architecture, like I told it, so the particular serverless architecture which we are going to see, it's going to utilize DynamoDB for data, and Lambda, it's going to be our DAO layer. So my Lambda function is going to talk with my DynamoDB, and it's going to get the data for me. And then, so it's going to pass an integration. So my API gateway acts as an integration layer from my client and my Lambda function. So it connects both. So that's how it happens. And we are utilizing S3 for presentation. Whatever you're seeing in your browser, that's going to be the something which comes from the S3. So about the, let's start before we are coming to serverless concept, that is Lambda. So what I'll do is, like, I will show the, I will explain you the application which I have built. So the serverless application. So parallelly we can cover this concept, so you will understand it better. Yeah, so this is my application, so which resides in DynamoDB. Yeah. Yeah, so sorry for that. Yeah, this is my DynamoDB table. So you can see that this particular table resides in my DynamoDB. So created a table called, yeah, so I've created a table called Meetup. So we can see there are two Meetup information that I've added in my listing. So this is my data tier. So next is my Lambda function. yeah, this is my pretty much my Lambda function. So what happens is you can see all the code in here. So it's a very simple code. So I've created a DynamoDB client, and I'm using that object doc client object in order to access my tables in the DynamoDB. You can see I've specified the table name and my primary key from where it needs to. This is my primary key. So uh, it accesses my table with this primary key and gets whatever it's mapped to my primary. So let's go back to our slide. So Lambda function is an implementation of PaaS, which we call function as a service. Okay, so what are the qualities of PaaS? It should execute logic in response to events. Like soon after you hit the S to execute a logic, and it's going to query the DynamoDB, get the data, and it's going to present it. Okay, so what data, use logic and all, it has been coded in a Lambda function. So that's it. And next is in this context, so function. So it is whatever you are trying to do. So through your function, all needs to be combined, and then it should be deployed as a group. Okay, which we call as function. So and next is I've showed a simple code, but even you can have a zip file. So we can upload a zip file. You can create a zip file, and you can upload that zip file into S3 from where you can read. So we'll see another application at the end of this session if we have time. So I have created a CloudFormation template as well, which it's very simple. So what will happen is you just need to go to the you need to import the CloudFormation template and click create stack so that it will deploy the entire serverless application. So you don't need to worry about it. You just click on the CloudFormation template and sit tight for 2-3 minutes. That's how your serverless application is up and running. So we are going to, if time permits, we will see that application as well, how we can do it. And next is packaging, deploying, and everything is handled transparently, so you can visualize it. So I'm an application developer. I've seen what it takes to deploy a web application to a WebLogic or a Tomcat. Okay, so that much complexity is not. It's very transparent, and the FAS makes it easy to write and deploy simple microservices. Not only serverless architecture. If you want to write a microservices, we can do it. In Verizon, so there are lots of microservices, which, for example, the tagging, for example, we need to remove the EC2 instance. So whenever there is it doesn't contain a name tag. So what we do is we use Lambda function for that, so which runs as a scheduled instance. So Lambda triggers. So these are the triggers available for your Lambda function. So you can trigger it from my API gateway, which we are doing right now, or else you can do it from AWS IoT Alexa, which is a voice-based service. Next is CloudWatch. You can trigger it from CloudWatch, Cloud Commit, Cognito, DynamoDB Kinesis, or simple notification service. So even, for example, CloudTrail doesn't have a which is used to track your API call details. Okay, so that doesn't you can't use that to invoke Lambda, but already CloudTrail has a. In such case, what you can do is CloudTrail has a facility to post that information. So that API calls information into your S3, which can in turn trigger your Lambda function. So that is going to be the event. So like I told, AWS Lambda is event driven. So AWS Lambda is event driven. So it requires an event. So what you will do is like, what is going to be the event which is going to trigger? So there are two types of event in AWS Lambda. So one we call as push event, and another one is called as pull events. Okay. So in case of push events, so S3 and SQS, those kind of things and all are push events. That comes under push event. For example, soon after I upload something into my S3 bucket, for example, if I needed to upload a photograph, it needs to be converted into a thumbnail. So that is going to be an event for me. User uploading picture into my S3, that's the event. So soon after it's uploaded, it triggers my Lambda. Okay, so that is a push event. It pushes the Lambda function. So there is another case like we are doing, it's pull event. So pull event in the sense in DynamoDB, what happens is if Lambda sees whether there is any changes in your DynamoDB, soon after any data is updated in our DynamoDB, it pulls in that data. Okay, so that we call pull event. So in case of push event, your event source mapping. So you need to map your event to your Lambda function. So that will happen in that event itself, for example, in that source itself. So, for example, if you're doing for push event, all the event source mapping will happen on S3, whereas other thing it will happen on the Lambda function itself. Okay, so that's a way around it. And also, Lambda function has some the basic concepts of Lambda function. So let me go back to this thing. So soon after, what happens? It's like you need to have a handler function whenever whatever the strategy for creating a Lambda function is common. So you need to have a handler function. So handler function is that's the one which is going to handle your event. For example, if I'm clicking on my browser, http meetupmojo.com. So that is my event, right? So that is going to be handled by my handler function, which you see there, exports.handler. Okay, so you can see that I'm passing the event data and the context and then callback. So event data is, for example, what is that particular event? Whether it's an S3 event, whether it was an API gateway call, those event information and the data pertaining to that particular event. So I'm passing, I'll be passing using this particular event object. Okay. So next is context objects, nothing but it provides a platform between AWS Lambda function and between the code which I have written. Okay. So the AWS Lambda, it connects both. You can see that soon after you start your Lambda function, it needs to interact with the AWS Lambda services. Okay. So that is part is taken care by this context object. Also, this context object, it return back to the request ID. For example, if you have a mobile application, so what is a mobile application calling your Lambda function? So those kind of information context. Okay, so that's what. So it acts as it's just an object which it integrates my code with the AWS Lambda services, whatever the function code I've written here. AWS Lambda services, and it makes it both to interact in order to do something. So that's what pretty much about context. Callback is so soon after everything has happened, I'm returning back some response. So that's what callback is, and this is what. So there you can see that next comes the param. So soon after I get from my URL, right? I'm getting the query string. So this is my query string, the meetup name. Okay, so you're going to enter the meetup name. So that is my query string. I'm going to get in the params. Okay, so you can see actually Lambda supports 4 languages, which is Node.js, Java, Python, and C#. Okay, so you can write in any of the 4 languages. So so depending upon that language, you can go for any of those according to your convenience. Okay, so and next thing is, so I specify the query parameter there, and once for everything there is an SDK as well. Okay, AWS SDK. So for Java, so I'll provide the links later after this module, so you can go there and you can see how we can contribute. So here I've created a DynamoDB object, right? So same way you can do it for all AWS services. You can just go there and refer. So there will be lots of available methods. For example, if it is EC2, so you can EC2 to describe instance. So that will give all your instance details into your Lambda function. So you can do. So it almost have all the AWS services. And next is I'm getting the whatever it's coming from my event. I'm passing my query parameter. That query parameter I'm getting in that params, and then I'm passing this particular params to my doc client. Whatever the meetup name I'm passing here, so it goes to my DynamoDB and it gets this particular. Goes to this particular table. and gets that particular, it matches what meetup name is having such information, and it gets all the details and it displays in the year. So that's how the whole process happens. So let's quickly test it. So we'll see the advanced configuration. So this is all about a Lambda function. It's a very simple function. So of course you can write a complex one as well. So next is we will see about the configuration. So configurations, it's like so soon after you're creating a Lambda function, you need to specify your runtime environment. Here I have used Node.js 4.3. And next is your handler function. So what is going to be an handler? So index.handler. Index is nothing but the file name, and handler is the handler, which is going to be an handler function. So here this is my exports.handler. So this is my handler function. That is the medium way you're taking, which is going to be my handler function, which is going to process my event data. That's what it does. And next is role. You need to, of course, provide an IAM role. I have already provided a IAM role which can have a read access to my Lambda DynamoDB. Okay, so whatever resources you're trying to access, for that you needed to have an appropriate IAM role so that you can access, your Lambda function can access it and it can get the data from that. So if you go to advanced settings, so yeah, so Lambda automatically allocates your CPU, network bandwidth, and disk input, output, those things and all. It's automatically allocated based on it's by AWS. You don't have to worry about. From user perspective, what you're going to enter is you're going to enter the memory. So how much time, how much memory you need. Just memory. Okay, so it is an increment. Okay, so we will see that it's in incremental stage. Okay, so based on this memory, okay, so you based on this memory, how much memory you allocate here based on this number of CPU. So it's directly proportional to number of CPUs that has been CPU power that is being allocated for your Lambda. More memory you allocate, more faster your Lambda function is going to be. So that's all. And another one important thing, I'm not sure whether that's very important or not. First time whenever you're executing a Lambda function, it's a bit slow. So you needed to think about it. Why it's spinning up the container. First time there is a container pre-warming happening. So might be the first request. So so you have not used a Lambda function so for a while, and then you're trying to hit it. Then it takes a while. So like it's very negligible, but I just want to tell you about it. So you're, for example, you're creating a very critical application, mission critical. Maybe in that case, it might be a matter. Okay, so that's what that pre-warming, why it needs to spin up the container for the first time. Next subsequent request, okay, so whatever you make, it will be faster. So it's a very slight negligible delay. And the next is, yeah, this is what you specify, memory, and you can see that you specify also the timeout. Okay, so how much time my Lambda function needs to execute. Okay, so you needed to specify that. You can do this through trial and error. I have said. So this 10 second, for example, whenever you're developing a code, it's a best practice to set this timeout period at an appropriate level so that you know how much it executes. Okay, so for example, maybe your code can have a recursive call which will be calling your Lambda function, so it will be running and you will be charged. So in order to avoid that, you need to how much time is my Lambda function code it's going to take to in order to execute that. Okay, so here I have specified 10 seconds. So if it goes beyond the 10 seconds, it's going to throttle this Lambda, that particular function execution. It's just that's all about this thing. So if you have a VPC configuration, so you can provide that here. VPC and subnet configuration, but for right now I've not used VPC. And next is your triggers actually. So you're seeing that there is no trigger here. It's because I'm calling from the S3. From S3, I have the client coded. I'll show the code. This is not pretty much code. So all my code which interacts with my API client. So the API gateway. So all this code is there. So you can see that there is an API client which I would have created in my HTML page, which has been uploaded in S3. You can see that I'm I'll be creating a so you can see that I've created an API client. Okay, so this API client, you can see the same method here. In this and all, only the meetup.html is created by me. In API gateway, there is another function where you can generate the SDKs for JavaScript or Android. Okay, so we can do that as well. So this API client.js and the README file. So where and all you need to update the scripts in my UI. So those things and all it will be contained in this README file. You can see that instructions, what and all I needed to do in order to interact the UI to the API gateway. So that information will be there. So all this are auto-generated except this meetup.html. There will be an library file as well. So you can see this is what it auto-generated. So JavaScript. So everything is preloaded. So I didn't do anything here. It came from the AWS environment. So I will show you in the moment when we talk about API gateway. So if you go to SDK generation, click generate, it will going to generate this whole zip file. So which later you can extract it and you can upload it. If you see, these are all the library files which is required in order to interact with my Lambda function. All resides here. All the dependency file. Yeah, that's how pretty much under monitoring. So this is a beautiful feature which I like. So it tells like how much invocation count came. So how many times my Lambda function was called. And next is invocation duration. What was the duration it got executed? So how much time it took, whether there were any invocation error, and whether it was throttled. For example, there is some, I told, right? So there is some threshold limit. For example, the number of concurrent function that can execute for a particular user. So it's like 100 functions that are capped. So that's a soft limit. Basically, if you need more than that, always you can go ahead and request a mail. So I needed more than 100 concurrent functions. So they can provide you that. Okay, so but there is a limit on that. So if it goes beyond that, then it's going to throttle that invocation. Okay, so that is one thing. And next thing, if it has any other error, so it's going to display it. So this is what pretty much important. So we will see about invocation count, invocation duration, invocation errors, whether there is any errors or not. This is the average time. So it took 932 milliseconds. Okay, last time. So when it was, and next time it was very less. You can see that like I told, the first time it gets somewhat because the container in the back it's warming up. Okay, so but subsequent thing it was very less. Okay, so the second and third request was very minimal. So that's obvious. And you'll be charged only for whatever the duration of time your Lambda function runs. Okay, so once it completes, for example, if it is charged on an unit of 100 milliseconds. Okay, for example, if I'm running for 40 milliseconds, also I'll be charged for 100 milliseconds, which is very low actually. So there is a low cost in that. So I'll share the URL where you can go and see the price details of this Lambda functions. Okay, so how much it costs for every 100 milliseconds. That you can see it. And so once this is a graphical representation of your log. And if you want to see the physical log, so you can click on this and so what was happening with my Lambda function, what it did actually. So those things and all those information you can see it here. Like this is my log stream, and so what happened? Okay, so what was the parameter it was passed and everything. So and I can see how much memory size it took, what was the duration it executed. So all this duration you can see it here. So based on this, okay, so first time whenever you're developing, of course, you may not be knowing how much time your function may take. Based on this information, you can tune your time duration at which your Lambda function executes.
Is the maximum limit, right?
It's it's a minimum limit. So it's not maximum limit is 300 seconds. Okay, so which is 5 minutes. So max your lambda function. Sorry, I forgot to mention about that. That is one of the limits. So which any lambda function can not run more than 5 minutes. Okay, there is a soft limit in it. So I think pretty much 5 minutes is more than enough for a microservice. So if you're going to decouple your this thing, so yeah, so there is a limit on that. And also, if you see, there is for example, 500 MBs allocated as a temp space. Okay, so where you can store something temporary details like we do in our instances. But so if you can't store anything, if you want to store anything persistent data, you can store it here. And then, so there is a lambda function can be of 6 MB, so a total package of lambda function. And dependencies, it's I think there is around 250 MB or something. Okay, limit on that. I'll show you the URLs. All the information are there, and that you can go and check out on that resource limit. So which lambda function has. So next, this is my lambda. We saw about our lambda, and then we saw about our DynamoDB. Next, go to a next session, API gateway. This is my data layer. This is my DAO layer, and next is my integration layer, which is API gateway. So you can test it here, your lambda function as well. So, for example, you can mock your this thing. You can test it here. I'm just presenting like so. I just passing the JSON format, which would typically pass from my UI, and then I click on save and test. So you can see that this lambda function will execute and display the results here. Typically, you can see that it has written, it has interacted with DynamoDB, and it has got all the details for that particular meetup. Okay, so that's how it pretty much works. You can test it your lambda function as well. And so next we will go to API gateway. So this is my API gateway. So you can see that just like I deployed my resource here in my API gateway. So since I have enabled cross-origin access, so there is an option function. So which gets soon after you enable CORS for API gateway, right? This option methods will automatically created by the environment itself. So which will, for example, if there is a call from your browser, so it routes it properly for that purpose. And next is your get details. So this is my method actually. So this will show how the whole flow happens. Okay, so my request is coming from the client, and then I've got the query parameters I'm passing. Client is sending me this meetup name. So I'm getting this in my method query parameter. And next, there is a lambda proxy, so which redirects that particular request to this particular lambda function which we saw, which is meetup details. And next, my lambda function interacts with the DynamoDB. It gets the data for that particular meetup, and then it changes. It passes back that response, method response to the integration response to method response. From there, it's passed on to the code. Okay, so that's how it pretty much works. And like I told, stages. So once you deploy it, so you can deploy your API gateway as different stages. For example, in order to test it, you can have a test stage. So later, once you confirmed everything is working fine, then you can go for a production stage. So that's how it pretty much happens. So once you have deployed your stage, what you can do is you can go here. And I told about the SDK generation, right? So the library files which I generated. So you just needed to click on here and take the what is the environment. For example, right now it supports Android or JavaScript, iOS, Java SDK, those things. So for me, since it's a Node.js application, I selected JavaScript and clicked on Generate SDK. Creates a zip file. So from this, let me open this zip file. You can see all this API gateway and README file, all are auto-generated. I needed to have only my HTML file, and from this, this particular API client.js will readme.md, right? So if you go to here, so you will see what is the method. If this particular app, if what I needed to do, like you need to replace the scripts, and then the params, how I need to pass. Those templates are there, and then the API client method which I needed to call. You can go here as well, so you can get the API client method here. So this auto generated template. So this is what my method. It's the same thing I needed to. You will see that it's updated in my yeah, the same method has been updated in my HTML page so that it interacts with my API. So that's how the whole thing happens. So that's all about this. And next, let's go to S3. So where I have my presentation layer. So we have done with our integration layer. So this is my application. So I have not enabled DNS. Okay, so if you want, you can enable DNS, and from that you can refer the S3 URL. So I've enabled a static web hosting. So you can see I've enabled a static web hosting here. And so this in my bucket, if you see, so this is my HTML page. I will specify whenever there is a call for my meetup.html, so it will access this particular resource, and then it will interact with the API client. And from there, it goes to Lambda, and then DynamoDB. So, and that's what I have mentioned here. So this is my URL. So okay. So you can try to hit the URL now. So you will see and let us. If you want, you can try to hit this particular URL from your laptop or mobile as well, so that you get the response. So let me enter the meetup name, for example. It displays. So all happens. The thing you can see. You will see that for this meetup name, it interacts with my from S3 bucket. Okay, so it will go to my yeah, from S3 bucket, it will go to the API gateway, and then from there, it will redirect to Lambda function, and from there, my Lambda function works in the backend, and it accesses the data from DynamoDB and it's back. So that's how the whole thing happens. For example, if I'm going to change it, okay, so that's how pretty much it works. Okay, let us add a record in our DynamoDB table and new record and see. This is my table, so items. Yeah, my next. Yeah, so I've added my details. Okay, soon after I say that, you can see that if I'm going to give that AWS, it's going to come to this particular super thread. Let's go back to pretty much that. Okay, so you saw that, right? So I've added in a DynamoDB label, so the same thing came in my UI. So that's how the whole process happens. Okay, so next let's go through. That's all pretty much. So what are the benefits from a business perspective? Okay, so cost is based on number of executions, so it's measured in milliseconds instead of hours. So if you go for EC2 instances, every hour you're being charged. So that's not the case with Lambda. And next is introduce more agile, smaller deployable units. Okay, so for example, if there is an outage in one module, you don't have to suffer. The whole web application will not go down. So that's smaller deployable units and faster delivery of features to market. Okay, so faster to our clients, so they can get benefit from it. So that's the power of serverless. And cost of hiring backend infrastructure. So it's also reduced. So you don't need anyone to manage your service. Okay, I hope system admins need to learn that. Okay, so next is business, but what are the disadvantages? Because it's like so less overall control. You can't control at the OS level. So there are certain threads and not threads process. Still, you allocate like 1024 threads process. That's the limit for function. So you can allocate that per user. You can allocate that still. Okay, but not beyond that. You need to do some process level or thread level activities with your Lambda function. It allows it, but you can't go to the OS and debug it, okay? Because you're not managing this, so everything taken care for you by AWS. So you needed to sacrifice that debugging capability. Next is security risk. So there is a security risk as well, so but it can be addressed. So you can secure your API gateway. So there are various ways. So I will share your documentation. Okay, so I've been covered in that, but maybe in future session we will cover out. You can maybe secure API gateway. There are different ways you can use access key, and you can use your the federations. For example, you can use your social accounts credentials also. It also supports OAuth login, so which you can use to validate your client and allow the API. So also you can use either if you're using, for example, in Verizon. So we don't use the API gateway much, but some of the functionalities has been disabled for security reasons. So what we do is we do it through RPG. So that's also possible. So if you're hosting your API gateway in RPG, so you can call your Lambda function from that aspect. So that's how it works. So all those caveats can be mitigated with open source alternatives. Okay, so whatever. So there is some vendor lock-in also. So let's, this is from business perspective. Let's see from developer perspective. So no backend infrastructure. So I don't have to worry about my auto scaling, load balancing. So I only worry about the business, my code, and that's it. And next is zero system administration. I don't have to struggle with auto balancing and bringing up my environment when something goes down. So fosters adoptions of nano service, microservice, SOA principles, so you can faster adopt it. And next is faster to get up and running, so you can make your app up and running in a few minutes. Okay, so it took less than 30 minutes now to create for me this application. So it's so much faster. So 30 minutes for simple applications. Okay, so with the EC2 instance, it's going to be hours together. And next is, it's not, I'm speaking of that when I needed to do auto scaling and load balancing. So auto scaling, it's somewhat complex in AWS. Get some monitoring out of box. What's happening? You saw that CloudWatch lots of invocation count happen. So what is the log details, when the request came, how much time it took, what are the parameters that passed. So all those details I was able to see it. In throttle levels, everything I was able to visualize. So from developer perspective, what are the disadvantages? Like it's somewhat immature technology. Okay, so we don't have some best practices on it. Still, the industry is exploring. Okay. Next is component fragmentation. We have lots of components, okay, so which is fragmented. And next is unclear best practices. What is the best practices which I needed to follow? Developers might be unclear about. So discipline required against functional crawl. So whenever developers are designing function, they need to be careful that my Lambda function access whatever that's required, and it's provide appropriate IAM role. So that, for example, if you need only a read-only access, I shouldn't provide a write access. So those things and all we needed to take care. So it should be restricted in a Lambda function. And so there is a multi-tenancy mode. So this Lambda function also, there can be some system ops behind the scene. I've not seen it actually. So it's just a want. And next is testing locally becomes tricky. So you can't test it locally, right? So I needed to go to AWS console. But I saw there is an alternative for testing Lambda function locally as well. But that setup is a bit complex actually. That's possible. And next is further limitation, significant restrictions around local state, like execution duration is capped. So I told like it's 300 milliseconds. That is 5 minutes execution time. So that is capped. So that is one of the limitations which we have. Next, experience in production. So this is about a company called Compelling Science Fiction Company. So they have used serverless function. So author application. So soon after email comes for some authoring, so some articles. So automatically they process it and using S3. So this application, how they have designed. So I've shared the URL. You can go and read this blog. So you can go. It's production grade, deployed in production. Then they are using it, so you can go through, and you can adopt some best practices from them. So maybe in Meetup community, I'll add up more production examples so that you can go and reference it. And next is adoption path. So this is one of the interesting thing. How I needed to migrate to serverless. Okay, so first you needed to ask these questions: whether it's going to be a greenfield or whether it's going to be a monolithic legacy application. So whether it's going to be a simple application or complex. What are my complex requirements? Okay, so you can pick up a framework and get started. There are lots of high-level serverless framework which you're going to see in a moment. And apart from it, legacy project need to be more strategic. Okay, so they need to strangulate your applications. For example, take a small bit from your monolithic application, migrate that only to serverless, and see how it works, and then slowly migrate every parts. Okay, decouple. So identify different tiers of your application and take small service within your monolithic application, and then convert it into a serverless application. Then slowly convert. Okay, so your monolithic application is also starting, and your serverless application is parallelly running. Okay, so soon after one it's tested, it works fine. Then get that particular module out of your monolithic application. That's all. So serverless framework. These are the serverless frameworks which is available. So there is one called serverless Apache, Cloud.js, Sparta, Goda, Zappa. So you can go and explore. Just Google it, you'll find it. Okay, some useful link. I'm not sure why this displayed. Yeah, so this is about some of the documentations which for VPC and then the security. I'll share it, this slide in our Meetup group so that you can go through this links and all. Okay. So let's open up for Q&A. So if you have any questions. I'm not sure whether I took too much time.
No, it's not at all.
Sorry.
It's okay.
Yeah.
Excuse me, one of the caveats that you mentioned, right? Like, I think you mentioned a very broad topic of best practices are not there from any kind of company, as opposed to trying it out from a hobby perspective. Any kind of team where you have more than one person contributing and all that, you need to have source control management of whatever is running.
Yeah, sure. Of course, you
Those
can
kind of
have.
things are also not possible, right? Because there's basically no IDE or code.
Yeah, so you can always have your source control for your Lambda code. Okay, so so what you can do is actually I showed you a decoupled one, so I will show another one, CloudFormation template. So just a moment. So there is a CloudFormation. What you can do is like you can do everything in a CloudFormation template, and you can deploy your code from your Git repository, Lambda function code from Git repository to S3, and then you have everything in a CloudFormation template and maintain that CloudFormation template using it, then everything is fine. So that's possible. So I'll show you that template. So since I took too much time, didn't show that. So I have a CloudFormation template. So I just create a stack. It will create the entire serverless application, seamless. So you can do that. I'll push all this code, everything to GitHub so that you can go and refer it. Try to show you. Yeah. So meanwhile, any other questions?
Actually, I'm a very beginner in this. I'm just trying to relate it. Where is whatever you said also here. Where in the relate this and where I can apply it.
Yeah, that's what I told, right? So any web application can go for serverless application. So first you need to take out a module. So identify your application, what you're going to do, what is going to be my business logic, that you need to decide. Okay, so what type of application? So whether it's a web application, whether it's a batch job application, so like that, whether it's going to be a streaming SQS, okay, something like that. For example, you can use Lambda with SQS. So first we need to identify the type of application. Next, so what is the architecture? What are my requirements for that? Okay, so based on that, we can design it. For example, you here, whatever application you're going. So if you go for serverless application, so you will use S3 for your presentation layer. All your presentation, the HTML files and the codes, the Lambda, even the Lambda code can reside in your S3 code. It's what you can do is you can do it there. And next is for DB layer. So you can use RDS. You need to decide like what is the database I'm using on premises. So the same version. So in RDS, it provides lots of clients. Okay, like you can do it for MySQL, Oracle DB, or everything. Based on it, spin up an RDS instance, and then API gateway. You can use either. So API gateway, it's learning Amazon API gateway. You saw that, right? So it was very simple. So create API, and then you just deploy the API, define what are the method which is going to come for my web URL, and then map it to my Lambda function. That's it. Even the JDK is generated for you by automated fashion. Much work on that. Okay, so that's how you need to do. First, decide what type of application, what are my requirements, and then whether it's going to be greenfield application. If it's greenfield application, choose any serverless framework. My previous slide, like this one. So it will help you to get started faster. So this serverless frameworks like this one, so they support you. Or else, if it's a greenfield project, it's a very fresh project which you're building from scratch. If it's a monolithic, then you need to gather that requirements, how it operates my application. So instead of migrating the whole application, take one small module in your monolithic application and migrate into serverless and see how successful it is. So incremental progress. Okay, so one module maybe this month, and the next module the next month, and the same way you will be incrementing. By at a point of time, you will have all your monolithic application to your serverless. So as you convert one module to monolithic, then take that module out of your server, out of your monolithic application, and see, ask the feedback from customer how they feel, and address that issues. Like what are the, for example, whether there is any latency issues or that. So because might be your backend resources might be having some latency issues, you need to get that feedback from customers, okay, and then you need to fix those things. So that's how the whole thing happens. Did I answer your question?
Well, he wants some use cases where can fit. Where can I use this?
Web application? I told like, see, Lambda is event driven. Okay, so either you can call it from HTTP web application. Next, you can do it as a scheduled event as well. For example, for every day 12 o'clock, I need to take a EBS snapshot. Okay, so that you can do it through Lambda function. Those So there are lots of examples actually. So if you go to the console, right? So already there is a lots of examples here. So if you create a Lambda function, you can just go ahead and play around this examples. Okay, so different modules you can play around, so you understand how you can access different modules. Okay, right? So there is an SDK. So for Python there is Moto 3, and for JavaScript SDK is there for JavaScript client. So so for Java we don't have a SDK, but there are lots of resources which helps you to build an application for Java as well, Java and C#. So that's. So I'll show you the URL, like the.
One another simple case, like I'm using Redshift. So in that automated backups are there, which is but with this Lambda functionality, whether I can do some extended functionality for scheduling kind of thing. Is it possible?
Yeah, if you are say consume cross usage reports and you want to load into your Redshift, you can have a schedule Lambda function that loads the data into that. But it can be triggered by an event because you are reports are pushed into S3. Listens to that and pushes those reports into Redshift. Or any other reports, for example, if you are pushing your manual reports,
Even whatever the metadata over in Redshift that we can
anything. You can access, you can run any arbitrary piece of code. The only catch is, correct me if I'm wrong, the only catch is you don't do any complex stuff inside it. It's not meant for that. Anything that's very simple, run it in a cron tab, you can run it on Lambda. Anything that's very simple, stateless.
So you want to do store something stateful, then you can go for Elastic Cache or DynamoDB or RDS.
I have a couple of questions. I think one follows the other.
And for the interperson, why don't we continue it after the break?
Yeah, we can discuss it.
Yes, sure.
So,
Because it's running out of time for the break.
Yeah.
break. Okay, so first question is, yeah, you guys can come have this. I don't know.
Snacks and coffee and stuff.
Yeah, sure.
So first question is, as a both the developer and an operations person, for me, control is something very essential. So apart from say managing operations in terms of somebody is managing my server, which though is truly not the case because just Lambda is pretty useless because it can only do cron stuff. Right? I need to have a bunch of other stuff if I want to build anything really useful or meaningful for the kind of pitch these applications are making. Like I need an RDS or I need an Elastic Cache, I need to have integrations with an SQS or an S3 or a bunch of other stuff. And none of these services are free. Right? We can say, yes, I can have a CloudFormation template or form or an Ansible script that can bring up the whole stack. I can do the same thing for my auto-scaling group as well. I don't know why people have that aversion in the first place. So apart from doing these very simple tasks like say EBS snapshotting, terminating instances when you really don't need them, or importing a bunch of stuff, what real use does Lambda really serve?
See, I told you they're running a production grade application. If you see, so maybe.
Yeah, I mean the cost. If you're gonna the architecture has a bunch of different integrations.
Yeah. So if you're going for, let us take, you're going for auto scaling and ELB. So for every EC2 instance, your charge on everything is a charge, right? For every service, it's a charge. Okay. So even if you're not, for example, take an EC2 instance, even if you're not consuming it, okay. So it's just idle. So you're going to
so
end
that's
up
the catch, right? So if I'm not using anything, I don't really have a question of scale, right? My systems that are really need to scale are the systems that are really user facing, and those systems are never idle. A number of invocations.
See, that's what even that system, right? So if you take a web application, so it receives a lot of loads at a stake. Okay, so that's what you needed to decouple that. So you needed to create it as a smaller modules. Okay, so in your web application, every module is not going to get the same load. Okay, so different modules will get. For example, if you go for a shopping application,
let's say I have a very simple Hello World application that people are really crazy about. Right? People just want to see a Hello World on the screen, and I get say 100,000 requests per second. Just arbitrary hypothetical system, right? It can be much complex than this. Now, 100,000 invocations multiplied by the minimum of 100 milliseconds, the cost I'm gonna incur just for Lambda, which is having a T2 micro instance or let's say 10 T2 micro instances serving is going to be much cheaper.
No, I don't think so. Lambda pricing, it's very cheap when compared to this thing. So if you go for
Based on what? You have a limit there, right? Because see, one of the drawbacks that you even talked about is cost is not predictable, right? When you're on the public cloud like AWS, any big enterprises who runs, they need any company for that matter. I mean, unless you have like $1 billion in your bank to spend just on AWS, you need to have some control. If you're an operations person, you would really understand that.
Yeah, I understand that. Actually, see, the whole purpose of why we go for cloud, it's like pay as you go, right? So whatever you use, for that you pay. So same way works for Lambda. If you see the every 100 milliseconds, that cost, it's very, very lower. So when compared to, if you take an EC2 instance, you take a use case, okay, so Lambda use case. If you compare both, surely it will be Lambda will be lower. So when EC2 compared to EC2, not only, so you're using lots of other services when you go for EC2 instance, right?
It's actually the opposite. Now with EC2, I get to control how do I want to, where do I run my database servers? I can co-locate with my application server. I can run my Redis with the same instance. I need not. I have a control. I get to choose what is the best practice depending on the type of load and traffic I want. But when I go with Lambda, I don't have a choice. I'm stuck with using RDS. I'm stuck with using Elastic Cache, and I need to pay for them. It's not free, right? Because I'm using Lambda, they're not giving it to me as a
no. So that's what we spoke about vendor lock-in, right? So
no, it's not a vendor lock-in. You take this whole paradigm of FASs, right?
Okay.
It just screws people up. It screws developers' interpretation of how a system runs. People have zero sense of what it means to run a system in production. They just say, I deploy. Which standard deployment supports zip file uploads? Seriously? I mean, I have this huge aversion with Lambda because it feels like some intern project at AWS. But what kind of a deployment system supports zip file uploads?
See, we are evolving, right? So, like that, our applications evolve. Okay, so it's not.
Yeah, I'm just saying.
It's
so
like it's like simplifying everything. So the whole purpose of DevOps, it's like simplifying things. Okay, so faster to market. So having that loop, so where and all we can optimize resources. Okay, so maybe there can be scenarios, exceptional scenarios where, like you told, there can be a web application which receipts have been low. So in that case, if you think it's advantageous, go for it. So but when it comes to microservices and serverless architecture, nano services, okay. So the whole point is like if you have Lambda, it handles well when compared to EC2 instance. Okay, so not it's not about having a big Lambda function. It's having a decoupling your environment into smaller components so that you can manage it well and it can scale it well across users, and you just pay for what you consume for that particular service. So that's all about it. I understand. Okay, so from developer perspective, okay, so it's like managing my whole system. It's like so if something goes wrong, if something happens, and maybe so
I mean, you can't even push those logs to another logging provider. And any production system would not use CloudTrail logs to manage your system application. You know that. You need to either use something like say a Splunk or Logly or some ELK stack, for example, if you're using the in-house ELK stack. Now,
yeah, I think there is an ELK stack within AWS. So
they give you Elasticsearch as a service, and then they give you other tools. But the point is that, again, you had another resource to the tool to solve this problem, another resource to the tool. And before you know it, your cost is already $1,000 per month for running a Hello World application, which has a few tens of requests. I mean, I don't even know how much are you paying for your demo application if you're going to use it.
It's free of cost. So 1 million requests it comes in free time.
How long?
Per month. For 12 months.
Yeah.
It depends on your business.
Yeah.
Precisely,
Your
right?
business
So
ready to pay, you can go with it.
yeah, I mean, that's always there. That's always there. I'm just saying, I'm not still convinced that this is something, I don't even, like, as an industry, that we are even talking this as a serious stuff. I don't know, this puts me off. How can, see, you have those pretty nice evolution stuff, right? Our ancestors are the folks who figured out how do you use transistors to do computations, are the folks who build distributed systems, are the folks who build mainframe systems, are the folks who build internet. now we are here trying to upload zip files to a Lambda function to run our machine.
Yeah, we are trying to simplify our lives. That's it.
Don't think about the entire commercial application going to deploy in Lambda. Lambda, there is a special use cases. One developer
Yes.
use cases, you can go with Lambda.
Yes, I see
If
that
you
as a
want to
cron
do-
tab replacement, a very good cron tab replacement.
If you want,
but nothing apart
if you
from
want to develop a fully commercial application like Flipkart, Amazon, then there is a separate stack. Go there.
No, it's not just, I'm not talking about the scale or that scale, even somewhere in between. I mean, folks like say Lambda or Azure Functions or whatever GC equivalent, it doesn't get marketed clearly. It sort of spreads a very wrong misconception. I mean, you busted a bunch of things on your first slide when you talked about what these are not. But also it needs to come out very clear. I don't know. It's more like a feedback or more like a discussion. Take it that way. No offense. So it sort of needs to come out that this guy is not really useful for building any of your mission critical applications. The term that you use, right, nanoservices or microservices, does not talk anything about scale. It just talks about your architecture composability. You split your into one huge war fight, or you split them into a bunch of different services interacting over a HTTP.
Yeah, so scaling we talked about it's like Lambda, whatever you design using Slade's auto scaling. So they design automatically.
Again, scales only to 100 concurrent invocations. After that, I'm locked. Then I
So
show
it's a
another
soft
request.
limit, right? You can always increase it. Just go and request arrays also to increase. I already mentioned that, okay?
Yeah,
So
you did
that's
that. I'm
the
just
on
saying.
purpose they have mentioned that soft limit. Okay, so whenever there is a soft limit, you can always go and increase it. So just send a request, they will increase for you. You don't have to worry much about that. Okay, thank you.
Thanks, Bharat. The great insights. Okay, take a break.
That's a lot of profit. So I'm interested in such discussion. So we can visualize what's where we are heading. Yeah. We can disconnect.
Okay. Screen or
Screen.
I think you're presenting the other screen. Do you have an extended view or a duplicate screen?
Mirror display போடுங்க.
Arrangement. Better?
let's just
Stop. Do it again. Okay.
we'll stopping it.
Can you again share, please? Yeah. I think make him
Yes.
Alexa, ask Meetup greet.
Welcome to Chennai DevOps Meetup.
So yeah, Alexa is welcome. For today, Alexa is going to be my personal assistant. So she can help me with the things that we are going to do. So
I can't find the answer to the question.
that's okay, Alexa, stop. Okay. Alexa, what is the weather in Chennai today?
Currently, in Chennai, India, it's 95 degrees with partly sunny skies. Today, you can expect mostly sunny weather, with a high of 97 degrees and a low of 79 degrees.
Alexa, ask Astra.
For AstraZeneca drug information, tell me a drug category. Vigerin, Beta, Arsiga Frixiga, Conbiglize, XR Conboglize, Ingliza, Cinnamon, Zygua, XR.
That are manufactured by AstraZeneca. So thanks to Alexa for helping me spelling out all those things. How are we achieving this? Or first, before going into that, what is this Alexa? Alexa is more like a personal assistant. This is from Amazon. So Google has got its own version called Google Home. So all these are voice-based command tools or command systems. So we can talk to that is we can issue voice commands, and we can get the responses. That there is a pretty good video about what Alexa can help, how Alexa can help you out, both in the personal home space as well as in the professional area space. So maybe you can go to the YouTube channel and then you can watch the video. I'll not get into that piece. So in AstraZeneca, we did perform a small proof of concept to see how we can use this in the medicinal field, or how we can improve the patient's understanding about the drugs. So that's where this proof of concept came in. So today we'll start with a simple application, and we will push it to Alexa, or we will push it to Amazon's cloud. That can be configured to our system so that we can access it, or we can publish our own custom apps. So when I asked Alexa for the weather in Chennai, so that is already a pre-configured app that is available within Alexa. So as Meetup welcome, they are the custom made, pushed it to the App Store, that is Amazon's App Store, and from there we have configured it to be rendered in this tool. So it's pretty much simple, and for this use case, again, thanks to Bharat for the serverless architecture in the morning. So we have used Lambda. So we have a small Lambda function that is working in the background to bring in these details to us. So there are no other servers involved, and it takes around approximately around some 30 minutes to publish an app into the store, if it is very simple. That is, if you are going with the complicated ones, then you may have to plan how you are going to perform those activities. So for today's the meetup one. So this is my Lambda function. So I have used the Alexa app. This is pretty simple one to use, and I think that there is a very good community who is supporting that Alexa app module, node module. So that node module is what I'm using for today, and it simplifies a lot of things. Otherwise, we will have to write lines and lines of code to bring up the scene. So in my first app, that is Meetup app, I asked Astra to welcome us. So this is the message that it gives me. Welcome to Chennai DevOps Meetup. So that is a response object. So I'm placing this message into the response object and sending it, and I'm ending the session with you, so that I need not have to continue my session, and my Lambda function ends here, given back to the end user. So here in this case, the end user is Alexa. So Alexa takes it and then converts it into wave format, and then reads it out for us, or spells it out for us. So pretty much like any Node.js application, I have to have a package.json to say what my application is about. So it's a boilerplate code that I have. I didn't do anything here. Everything is if you say npm init, you get all these things by default. This Alexa app as a module dependency. So once this is done, then what I will do is I'll create a zip file. He had the inline code in the Lambda function, right? So instead of that, I'm what I have done is, and I'm porting this zip file into my app. Okay. So I have created a node function called welcome meetup, and this is using runtime of Node.js 6.1. Like how he covered in the morning, the configuration remains the same except the inline editing part. So instead of inline editing, I'm uploading a zip file. So that zip file is the one that you saw in the local, that is archive.zip. So I take this archive.zip and upload it there. The same configurations that. So a handler, a role. So I selected an existing role. So in this case, for me, the trigger comes from the Alexa skills kit. So I have added Alexa skills kit as my trigger point. When I talk to this box can request, or this box can invoke the Lambda function that we have here. Monitoring, pretty much the same thing. There is nothing much I have done here. Okay. So this is the Lambda function piece. So once this is done, then the next piece that we will have to do is to get into a developer portal of Amazon and then create the skills. How the code is already available in the Git, so I have placed the code for today in Git. So this is a handle that you have to use. So you can take it from there, and then and you can create your own zip and then upload it to your Amazon account. So if you have Amazon account, you can even try it out now. Otherwise, I can show you what other configurations that we have to perform. So here, in order to perform this activity, you need to have a developer account in Amazon. So I already have a developer account and I have logged in there. So if you go to developer.amazon.com, you will see different tabs. So you have to select the third tab, which is Alexa. And the next thing is, as I have selected the trigger as Alexa skills kit piece. So here I already have multiple skills available for me. So the skill that brings in the meetup is meetup welcome. So if I click on it, session. You create a new skill, it will ask you for a set of details. One will be the application ID. Application ID from the previous one, that is the Lambda management console. So if you go here, the top one, ARN, is your application ID. So you'll have to copy that application ID and place it here. Then you need to give a name. and this is the invocation name based on which your Alexa will map the handler. So when I say ask Astral or when I say ask Meetup, this is the name that I'm spelling it out. So you'll have to give a proper name, and this should be a unique name for you. So this is more like a brand that you're going to publish across. So you have to be careful when you select the invocation name. Next comes the interaction model. Before we get into it, we have to know a few things like intent, the slots. So intent, okay. To make it simple, what I'll do is I'll show you how I took the intent, and then given it, maybe in the next thing I can explain how these intents are all created. So this is my local environment. So I have a Alexa server that is running locally. So when I all I have to do is I have to start the server. It's a node server. So all I have to do is I need to say node server. It starts up and it loads all the applications into the memory. So now I can access the same application within my local. So if I have to access the application of drug info, then I'll have to. So this is where it comes in. So here I need to select what is the request that I'm going to place. So let me select a launch request. So it gives me a set of code or configuration. This is the configuration that I'm going to use in order to test my app. So even if I copy this and then place it in my Lambda management console, it will give me the same response. So here, if you see, your intents and responses will be coming in. So when I say, you see, it gives me the response here. The schema is already defined here. So this schema is what I take and place it in the intent. So how do I come up with this schema and intent? I'll show you in a moment. So then comes the utterances. Utterances is how am I going to talk to Alexa, or how am I going to interact with the system? The utterance piece. So these are all the different utterances based on which the same intent will give me the responses. So you'll have to do a kind of trial and error here, and then you'll have to understand how different people talk or different people ask for questions. So you have to do some analysis here to bring to add utterances to your app, because the way people ask questions differs from one country to another country, even one state to other state, one person to other person. So you have to understand what are all the different scenarios in which people will ask different kinds of questions, and you will have to fill in this detail. So how is it getting displayed here? It actually comes from the code again. So if I get into my code, okay. So at the top, I'm saying utterances. So here I am listing down the utterances. I have hard coded it because this is for a demo purpose. I have hard coded it here, but this is where you will be adding it. You can even have a separate database where you can add utterances as and when it comes in, and you can connect to the database, or you can bring the details from that database to here, so that your application need not have to go for n number of iterations to production. Okay. Yeah. Similarly, intent is also listed here. I'll be listing it here only. I'll show you in another example. So similar to how I created the utterances, I'll be creating the instance and slots also here. Okay, let me come to what slot is. Give me a moment before we come there. So any doubt till now? Okay, slot is if I have to ask a question, or if I have to pass in a value to Alexa, so that Alexa can do the rest of the things based on the value that I pass in. That's when slot comes in. So there are custom slots that you can create. There are also some default built-in tasks that are available. So slots that are available. So you can use that those slots also in your application. So it depends on your use cases. So in this case, to understand how the custom slot works, I have created a custom slot and then added it here. So when you create a custom slot, you will have to configure the slot in your console. So if I have a custom slot, I'll have to add the details here. Type here, and what all the probable values that we can have for that slot. So that value will be entered here. So you'll be adding it line by line, one after the other in here. So this is where I'll be entering the Lambda details. And right now, Lambda is supported only. Sorry, Alexa skill is supported only from North American region. So that's why I have selected the. Okay. Let me come to this account linking later on. Right now, I don't have any account linking to be done, so I am just clicking it here. Here, I can simulate and then I can see how it works. Okay, it's muted here. I don't want to publish it so that general public can use it. So I'm stopping it. I'm not giving other details here, and I'll stop this one here. I'll make it as a testing piece so that it works only in my account and not in others' account. Others will not be able to see it. If I publish it, what happens is I go and search here. I can find the skills that are published to everyone, and I can register them. For example, weather is a published event by Amazon. So this weather is the skill that is helping me to details. So when I asked weather about weather of Chennai to Alexa, Alexa was actually calling this skill details. Because my developer account is linked with this Alexa account, my skills are listed here. So all these are my custom skills that are listed here, and this is in public domain because I have not yet published it to everyone. So once the registration is done, now my Alexa, this system knows what are the skills that I have and what skill is registered for me and what is the utterance on which I have to trigger that skill. So this system listens for the keyword called Alexa. So the moment I spell out the word Alexa, it starts listening for the command. I'll be saying ask or what is different commands. So and followed by that will be the utterance configured here. So based on that utterance name, it maps it to an intent. The intent is already created in the Lambda function. Intent is the Lambda entry. So that intent is triggered. Now my Lambda function is triggered. Now my Lambda function does the activity response. That response is sent to Alexa skill. It converts it into a wave file, and then my the small Alexa speaks it out. So that's the entire flow of how it works. So you can try it out if you whoever has got Amazon account, you can try it out. The code is already available in Git. So all you need to do is you need to check out, you need to clone it, do an npm install. You will get all the modules, package it, add it to your Amazon Lambda. It starts working. Configure it in your developer account, and to test it, you need not have to depend on this box. You can even go to Ecoism website for testing. So now with this, you will be able to test it. So you will have to press here, or you'll have to press the space bar. That the processing will happen the same way how it happens from this from the Alexa box. Log out from here because I don't want two things. Yeah, this covers it. So any questions on the configuration piece or anything?
If the Alexa does not find a skill set for some of your questions, will you be able to search the public?
No, it will not. Whatever you register in your skills portal, that's what Alexa will be aware of. It's more like your mobile phones. So you have some app in your mobile. So whatever app you have, you will be able to access it. So if you want a new app to be available to you, you have to register it or you have to install it. Same way you will be doing it here in a portal. There is no difference in an app that you install in a mobile phone and a skill that you add it to your Alexa. Yes. So Alexa has got a limitation in terms of the response time. So the timeout, the maximum timeout that Alexa can wait for a response to come to it is 300 milliseconds. 3 seconds. Sorry, 300 seconds. Yeah, sorry. It's not 300 seconds. It's 3 seconds, 300 milliseconds. Yeah, the first one is correct, 300 milliseconds. So it expects a response to be given to the Alexa skill within 3 seconds. So if it goes beyond it, Alexa will not be able to satisfy the requirement that you have. Very careful about the performance of the Lambda function as well as the kind of activity that you are going to do. So unless otherwise you have everything in the memory or within within the Lambda, Alexa will not be able to serve it. But still, I have tried few of the web services and it works fine, pretty good actually. Only concern is that everything should come within 300 milliseconds. So if you have the time boxing properly, then things works like anything. It's really good actually.
You have seen here, you have given for one question for like getting the medicine name. Right? So you put a lot of possible questions.
Yes.
So isn't it very big task to maintain all type of projects?
So as I mentioned, if you are going to have everything within the code, then it's tedious and you'll be doing the deployment of the Lambda function again and again and again. So instead, what you can do is you can have a Redis or for this. Instead of hard coding it, talk to that person, get the details, and then you can build the utterances. So that makes life simpler because whenever a new kind of utterance comes in, you will just go to and add the details there instead of having it in the function and redeploying the function again and again.
So how do you map that, for example? So this is for one question, right? So let me adding some more questions. So
you will have to create new intents. So how do I add it? So if you see here, this is an intent for me. So if I have multiple questions, then I'll be having multiple intents. That is, each and every question is going to be different for me. So I can have multiple intents, and each intent can serve me for different purpose. And you can think of reusability and other things. So in this case, what I've done is return here. This is just an entry point for me. But here, if you see, I have okay. So I'm creating a new instance of drug helper. Drug helper is nothing but another class that I have defined here. So all my drug details, everything I have it here, and from here all I'm doing is based on the category that I receive, and then I send back the responses. So So now the parent one, app.js, this becomes very simple for me. There is no business logic available here. So I can create multiple intents here, and I can have the helper classes. So all my business logic goes into my helper, and this is just an entry point for me. So that's how it works.
Basically, is multiple medicine names, right?
Yes.
For example, I'm trying for diabetes and some other diseases, right? So immediately, if you ask consecutively 2 times, will it give properly, or how it will take the data?
Okay, it will. If you are going to give multiple drugs at the same time, it depends on the way you define the utterance. So here, if you see, I have given only one utterance of my slot, the custom slot. So if I give one more detail, that is, if I spell out multiple drugs, it will take only the first one. The second one is ignored. So there is no multiple requests that goes in. So if I have to have that facility or feature, then I have to add I have to change my utterance in a different way. So I'll have to wait for a pause and then get another category. So without a pause, you will not be able to get another category or another drug category, right? So you have to configure it accordingly.
Suppose the same question, like an extended question of what you asked, what are medicines AstraZeneca is selling? If the keyword over there is missing, another person is talking with the same of that. How
we have to build the
all the synonyms I need to mention it.
We have to build it accordingly. See, right now, as I shown here, it's just a map that I have, and in this map, these are the drug categories that I have mentioned. So if you want to search by a drug name, for example, Foxygal, Alexa will not be able to tell you the details about it. So if you want that detail, you have to change the way this dictionary is built. So we have to bring in all the drug details also, and we have to give utterance details of what that drug is about. Or if I say Foxygal, when was Foxygal manufactured, and when was the license received, when is the license getting expired, and how many lives were saved by it, what is the generic name, what is the scientific name for it. So we can give all those details, but provided we have to build the dictionary for it, so that we will be able to look up for that specific drug and then send back the response. So again, I have to change the response also in that case. I cannot give a generic response. So here, instead of getting the response directly from drugs, I'll have to change it. So now I know that I have to spell out all the drugs that are available in that JSON. So I have taken that detail and then sending it. I'll have to now format the response, and then I have to send it across. Okay. Probably I can show another example where I have done that.
Earlier you shown a window like in AWS.
This is
there is a type you shown in AWS window. There also we can mention this combination of weights.
So this is another example that I developed. Here, what I'm doing is I'm getting the flight information or the airport information by making an AJAX call to external system. So if I get into this data helper, this is my endpoint. So I'm making a call to the services.faa.gov, and the input that I'm passing is the airport code. So if I give the airport code, it will tell me whether this airport is delayed or is it on track, what is the weather in this airport. So all those details are given to me there. So now I have to format the responses. So response formatting is happening here. Apologies, this is completely into Node.js, so if you have to bear with me on that, please. So here I'm saying I'm taking the details. I have a template. So in this template, I'm injecting the dynamic values like status name, average delay, reason for the delay, weather. So all those details are up and added, and then I'm returning it back. So I have not done this kind of thing for the drug search or drug information. So we have to do this piece. If I need a dynamic information about what the drug is and how the drug is helping the people. So let me not go in depth into it because one is time constraint and the other one is I'll get enthusiastic about telling all the details and I'll be so real-time use cases. Where can I use this? A simple thought that came to my mind is IRCTC. So instead of me going and typing and then searching for this, if I have Alexa and if I have a skill, so all I have to do is I should ask Alexa to search for a train and then book it. So the rest of things will be done by that. So how can I do it? I need to have an account with IRCTC. Without that, I cannot. So if I have an account, how will I register that account with my Amazon? So that's where the account linking piece comes into picture. It's not only IRCTC. You can link your Gmail account or any other account, even your corporate account, with your Amazon. How will I do it? I'll have to get into the Amazon portal. If I go to the previous one, configuration. Here comes the account linking. So if you have an external account and if you want to link it with your Amazon, this is where you will do the linking. So the moment you say yes, it will ask you for, this supports only OAuth. So SAML-based authentication is not supported here. I don't know whether why Amazon is restricting us to go for OAuth, but yeah, pretty much Twitter or Facebook or Google. So we can definitely have an authenticated session with Twitter. So if I have linked my Twitter account, so I can ask Alexa to tweet about the meetup today. So I have not configured it here.
How securely the password is maintained here? For example, giving username and password to Alexa.
Right. So number one, first and foremost thing, I have to trust Amazon because I don't know what is happening behind the scene for me. So yeah, I have to trust Amazon. But what they claim is that this account is linked only with the Amazon account of ours. So they are claiming that this is more secure. But still, I have to trust them on this piece, and I don't know what other things goes in the back.
For OAuth, you don't give your password. There's no password.
Yes, for OAuth, you will be giving the password. In the sense, you will go in your when you register the skill.
You give a token. You don't give a password.
Yeah, when you register a skill, it will ask you for a username and password. So you take the username and password and you create a token. So in this piece, I'll be forced to give my credentials. So I still am not sure how it is secure, how secure it is to give this detail.
They will initiate an OAuth request, which will
OAuth request will be initiated. It will go to our URL. So the endpoint URL that we have configured, that we will be configuring it here. Here, authorization URL. So the moment I go to the Alexa, you'll get a feature called link account. So when you click on the link account, it will take you to this URL, the URL that you give here. So in that URL, you'll be asked to enter your username and password. So the moment you enter the username and password, will be generated and token is now available with the skill. So for subsequent things, the same token will be used. So you need not have to enter in details. The question for me is, when the redirection happens, the control comes to me now. So when I enter my credentials, is it getting transferred in some way or other to Amazon? I'm not sure about this. So
you do username and password at Twitter or Gmail or Facebook, wherever the authentication gives you back a secret token.
Correct. Yes.
With the session.
Hot token is what is given back.
With the scope, whatever scope you define. So what? So your password only your service provider knows. If you have a password in Gmail, only Gmail knows your password, not anything else. But the permissions you give after saying hello, this app has all the permissions. Yes. That's the gotcha.
I have a question here. I'm just curious to know, like, what if there is a bank transaction involved in your this thing? For example, you were actually giving an example, where you quoted, what if I actually want to book my train tickets? So definitely there is a bank transaction involved. So how will Alexa?
You will have to link another wallet to your system.
Will I be able to do that?
It all depends on how you design the app, right?
And
it should be your app's feature, not the Alexa's feature. So you will have to link one more account.
yeah, true. But again, there is something called the OTP or your password grid. So how will I be able to do it here?
So we have to it's not a straightforward thing to do. Even if it is going to be a credit card that I'm going to use in India, then I'll have to enter in PIN or I'll have to enter the OTPs. So it's not a straightforward thing. You have to talk to the bank and then come to an agreement on how the app is going to interact with them, or you will have to have a gateway in between, and through the gateway you have to talk to them. It's not a direct credit card linking. So you will have a gateway or a payment gateway system that you can configure to your application. So this payment gateway's duty is to interact or liaise between the app and the third parties.
So currently, a lot of applications apps are automatically detecting the OTPs.
Yes.
Yeah, as long as it is mobile, OTP can be detected. But here you don't have the mobile concept coming into picture. So that's where you will have to talk to the wallets, mobile wallets. Even mobile wallets, they have restrictions now. Even they are asking for OTPs. So you have to have a customized one. Okay. Yeah, that's it. Any other questions?
Is it possible for us to have conversation with Alexa? Because so far what we saw is like ask some questions and was giving some straightforward answer.
Yes.
For example, I have a use case like I will ask Alexa to trigger a Jenkins.
Yes.
So it will trigger a Jenkins. After 5 minutes, I'll be asking Alexa. I won't be telling the keyword Alexa start. I won't be telling. It should keep listening and I will be asking complete or not. So
We can definitely do it.
Have what are the questions I have asked recently? You should have it in memory and it should go to the same Jenkins that you check.
So yeah,
So is it possible for us
the use case that you are talking about, the way we have to call the skill is a built-in intent called open. So in this case, what you will do is, let's assume that your skill name is Jenkins. So you will ask Alexa to open an instance with Jenkins. So you'll say Alexa open Jenkins. So now Alexa knows that this is related to my skill Jenkins. So from then onwards, whatever you speak will be your intents that you have configured in your app. So in that way, you can have a conversation between you and Alexa for Jenkins. So you'll have to open the skill and you can start talking to it.
I don't have to tell the for Alexa again and again.
Not required. For example, even in drug search, it was waiting for me to give the drug category in the second utterance. So the first utterance, I just said ask Astra, and I stopped it there deliberately to spell out. And then it prompted me. So if I wait for some more time, it will re-prompt me. Just a second. Alexa, ask Astra.
For AstraZeneca drug information, tell me a drug category.
So I'll not tell anything.
There was a problem with the requested skills
I spoke.
response.
Alexa, ask Astra.
For AstraZeneca drug information, tell me a drug category. Example category can be diabetes or cardiovascular.
Diabetes.
Hydrogen, beta, or C.
Alexa, stop. So this is how you can have interactions with Alexa.
But it won't remember like as you said, like 30 minutes or 20 minutes later, right? It's all like one transaction.
If you open it, it remains till you end the session. So it depends on how, when, and how you are ending the session. How to tell how to end the session. It's a simple thing. All I have to do is I have to say whether I can end the session or I can continue the session. So that is available here. Should end the session. So if I say false, that means my session will not be ended here. It will continue to remain. So when I want to end the session, like when I come to the last piece, and the session gets ended. That's a keyword that we'll be using.
Model your entire application as a state machine.
Sorry?
Model your entire application as a state machine and then keep processing it.
As for the long standing things, for example, like if I have to link my Twitter account and then if I have to talk to it, for example, let me say the moment I wake up in the morning, this is available in the video. So that person will wake up and then he'll say what are the appointments that I have for today. So Alexa will start interacting with the Google Calendar and take out all the appointments, and then it will start speaking about what are the appointments. So similarly, we can do it. So for long-standing ones, we can open the session and then we can go endless. Otherwise, it is preferable to end the session then and there, and then create a new session whenever you want.
Is there a way you can force Alexa to speak from, say, my Lambda function where I want it to act as a reminder for me? So can I have a Lambda function that will trigger a response which will say, you have an appointment with, you have a meetup starting in 10 minutes. Instead of my phone reminder, can I ask Alexa on my desk to speak that out for me?
We can do it. So Alexa has got, it has got the timer. So the way it does is, the moment you register with the Google Calendar, then you can set the reminder. And even you can add tasks. Alexa, add a task.
What's the to-do?
To go to Chennai DevOps Meetup.
I've added go to Chennai Meetup to your to-do list.
That's how it will do. So this is a to-do one. So if I have to have a reminder, I need to link with my Google account so that I can have the reminder set there.
That is what I'm asking is, from my application, can I push notification or push speak this out?
That's what I was thinking about, like when Jenkins will fail, you want to get
a notification.
Fail.
Okay. So this is a long-standing discussion that we are having. So we still have not come up with a proper thing. But looks like it's a possibility, but still I have not yet explored it, because one more Lambda, and on top of it I need to have a gateway, and this gateway should be triggered by my Jenkins build.
So that's the simple part. So the thing about, let's say even I can have a Lambda in a cron, a schedule which can push something, but it sort of also opens another kind of worms of then I can have advertisements being pushed into Alexa out and they'll just go on and infinite. So it's sort of a double-edged sword. So I'm just trying to understand.
Right now I have not found a way to do it. I don't know whether we have a way to get it done or not.
There should be, because it's sort of timer for, say, set a timer for 1 minute. After
we can set alarms.
Speaks out. So something, there should be a way.
We can set alarms. Alexa, set an alarm for 12 o'clock.
Is that 12 noon or midnight?
12 midnight.
Alarm set for midnight.
So I can set an alarm. Will be triggered at that time. But is it going to be a reminder kind of thing? I still am not sure. And the only thing that I've tried is this alarm. So this, even without anything else, it comes up. So instead of reminders, instead of setting it as a reminder, we can set it as an alarm. That's
also have an app where you can, through that you can trigger. One challenge is the accent. It does not pick Indian accent really well.
Yes, and this is even not available in India yet. As I mentioned, the Lambda that supports Alexa Skills Kit is only available in North Virginia. So we are dependent on that region. So and currently the language support is only UK English and Deutsche, that is German. Only 3 languages are supported. Indian accent, Alexa is able to pick up, and even kid used to play with it. He will ask Alexa to sing a song. Unfortunately, it is not singing Twinkle Twinkle Little Star. I don't know when when Amazon team is going to come up with that one. But they improvise on based on the request that we ask. So the first time when I received, when I asked Alexa about the age and the birth date, so Alexa was not able to tell it. But now, Alexa, what is your age?
Not listening.
Alexa, what is your age?
I'm 2 in human years, 14 in dog years, and 25 in cat years. I think AI years are marked by nanoseconds, so that makes me like a trillion.
So all these information. So initially, that is some couple of months back, Alexa was not able to answer this one. So it will say that I don't know how to satisfy your request. But now, with a new intern saying how to understand this kind of question, and it is giving us information. So they are also building based on the utterances that we make or the way we use it. Any other questions? I hope it was informative. Thank you.
So thank you, Sundar. Great insights on Alexa skills. And thanks, Bharat. There is more information on your session. We learned a lot. This is a small compliment from Chennai DevOps Meetup. Yeah,
You only get that once.
Oh, you have to speak 10 times.